This lecture is going to cover some of the simple gas laws. These are laws that relate two of the properties of gases to each other. First up is Boyle's law. Boyle's law involves the relationship between pressure and volume. It says that the pressure of the gas is inversely proportional to its volume. This is at a constant temperature and a constant amount of gas. And as the pressure increases, the volume decreases by the same factor. Or as the volume increases, the pressure decreases. This makes most sense if you think of having a balloon that has a certain amount of gas in it. If you somehow squish the balloon to decrease its volume, then you're going to increase the pressure inside of the balloon. The way we typically write Boyle's law is P1 times V1 equals P2 times V2. So we can relate a change in pressure to the change in volume. Here is a molecular view of what's happening. Pressure is caused by the molecules striking the sides of the container. So if you decrease the volume of the container, the molecules are going to hit the side of the container more often, and that will increase the pressure. So you can see here is a certain volume with a certain pressure, 1 liter and 1 liter. If we decrease the volume by half to half a liter, we increase the volume by that, or increase the pressure, by that same factor. So our pressure goes up by 2 when our volume decreases by 2. And here's a link to an experiment if you want to work that through yourself. Boyle's law also applies to scuba diving. Water is more dense than air, so for every 10 meters you dive below the surface, the pressure on your lungs increases by 1 atmosphere. The problem with that is if your tank contained 1 atmosphere of pressure, you wouldn't be able to inhale it into your lungs because you can only have enough force to overcome about 1.06 atmospheres. And if the pressure is 2 atmospheres outside and only 1 atmosphere in your tank, you can't pull it in. Which is why scuba tanks have a regulator so that the air from the tank is delivered at the same pressure as the water surrounding you so that you can breathe that air in even when the outside pressure is large. So breathing involves kind of working against the outside pressure to expand your lungs. So that outside pressure needs to be very similar to the pressure of the air you're breathing in. Here's a practice problem for Boyle's law. A balloon is put in a bell jar and the pressure is reduced from 782 torr to 0.5 atmospheres. If the volume of the balloon is now 2.78 times 10 to the third milliliters, what was it originally? Answer in liters. So the real trick to this problem is keeping the units straight. So I'm going to write initial. We are at 782 torr, final 0.50 atmospheres, original, the volume of the balloon is now, so that's final, 2.78 times 10 to the third milliliters, which I can easily convert to liters. That's, it's 2.78 liters. I want to find this in liters. I'm going to convert my torr over to atmospheres. It doesn't matter which way you do it. So I know that there are, from that table, there's a table in your book or it's back in the first lecture, 760 torr is 1 atmosphere. So I can find what my initial pressure is. So my initial pressure is 1.03 atmospheres. Now I can use my Boyle's law, P1V1 is equal to P2V2. So 1.03 atmospheres times V1 is equal to 0.5 atmospheres times 2.78 liters. If I work that out, I get an answer of 1.35 liters as my original volume. And I can check that by thinking through Boyle's law. My pressure decreased, so my volume will increase. So my pressure went from 1.03 to 0.5. My volume increased from 1.35 to 2.78. And there's my correct answer. Our next law is Charles' law, and it involves the relationship between volume and temperature while keeping constant pressure and a constant amount of gas. It's important to note that this only works for temperature in Kelvin. You need to convert over to Kelvin from Celsius. The way you do that is you add 273 to the Celsius temperature. And so if your temperature increases, your volume also increases. Temperature measures how fast gas particles are moving. And so if your pressure is staying the same and you're increasing the temperature, something else has to change. The volume is going to increase. Charles' law also relates to what's known as absolute zero. So this is why our temperature needs to be in Kelvin for this law. If we plot volume versus temperature for any gas at a constant pressure, it's going to fall in a straight line, and all of those lines converge down here at a point that's known as absolute zero. So if we extrapolate back to a volume of 0, we get a temperature of negative 273.15 degrees Celsius, which is 0 Kelvin, and that's why we're adding the 273.15 degrees to our Celsius to convert from Celsius to Kelvin. So let's practice using Charles' law. So the temperature inside a balloon, again, I'm going to write initial and final, was raised from 25 degrees Celsius to 250 degrees Celsius. The volume of the cold air is 10 liters. We want to know our volume of our hot air. Now we need to convert both of our temperatures over to Kelvin. So we're going to add 273. And so we get 298 K for our initial and 528 K for our final. And we know that V1 over T1 is equal to V2 over T2. So 10 over 298 is equal to V2 over 528. We can solve for our final volume, and we get an answer of 17.7 liters. And that's just cross multiply and divide like you do with ratios like that. So 17.6 liters. Our final simple gas law is called Avogadro's law, and it says that the volume is directly proportional to the number of gas molecules. So V1 over N1 is equal to V2 over N2. And again, this is going to be at a constant pressure and temperature. And again, this one should make some sense. The more gas molecules you have, the larger volume you have. And we can count the number of gas molecules by moles. And it's important to note here that equal volumes of gases contain equal numbers of molecules. the identity of the gas does not matter. So it doesn't matter if we're looking at moles of oxygen, moles of helium, they're all going to take up the same volume. So one more problem, if 1 mole of a gas occupies 22.4 liters at STP, STP is standard temperature and pressure, that just means a constant temp and pressure. What volume would 0.750 moles occupy? Well, we know V1 over N1 is equal to V2 over N2. Here we don't have to do any conversion. So 22.4 over 1 is equal to V2 over 0.750. And so we just multiply 22.4 times 0.75. And we get a V2 equal to 16.8 liters.